Hi everyone. Today we're going to review tectonic plates, what they are, and we're also going to look a little bit at how they move. We're going to talk about three types of tectonic plate motion. If you should need me, my email address is on the screen, but it's rcrawford@jcpsmail.org. So as a reminder, when we talk about tectonic plates, we're simply talking about one huge piece of Earth's outer lithosphere. So the lithosphere is not a solid outer shell. Instead, it's broken into these huge pieces. Some of them contain a continent, others do not. But we call those huge pieces of the lithosphere tectonic plates. Now, sometimes students come into class, as I've reminded you before, and say, oh, tectonic plates, those are things we find deep under the earth. They are not hidden deep underground. When you go outside and play, you are standing on the surface of a tectonic plate, because remember, a tectonic plate are just these huge chunks of the surface of the earth. Even though this picture is very handy to help us understand that plates are separate things, I want to point out that there are no gaps. There's no open space between these different pieces of the lithosphere, between these tectonic plates. And whenever we have a place where two plates come together, we call that, as you'll remember, a plate boundary. So any place two plates come together. Lastly, as a reminder, you can see that most of these plate boundaries happen to be on the ocean floor, on the sea floor. Now, when we talk about ways that plates move, we have three different types of motion. Okay, and so as a result, sometimes these are referred to as the three different types of plate boundaries. The first type that I want to have you think about is something called a divergent plate boundary or a divergent boundary. At a divergent boundary, and here we can see if we look at this diagram, we have one plate and a second plate. So right here is our plate boundary in between them. And we have this plate with an arrow on it that is pointing this way, and we have this plate that is with an arrow pointing this way. At a divergent boundary, the plates move away from each other. So these right here at this boundary, these plates are simply moving in opposite directions. When you think of divergent, I want you to think of the word divide, right? So they're moving away from each other. Let's compare that to a convergent boundary. So a convergent boundary, so notice once again, we have two plates. Here's our plate boundary. But notice how this time the arrows are pointing toward each other. That means that at a convergent boundary, the plates are going to move towards each other. And a good way for you to think about this is that they're going to collide. Finally, our last type of boundary, once again, two plates. Here's our plate boundary in between. Notice that the arrows this time are sort of moving in opposite directions, but they're not moving away from each other. They're kind of moving past each other. We call this a transform boundary. So at transform boundaries, tectonic plates grind sideways past each other, but moving in opposite directions. So our three types of plate boundaries, once again, we have divergent boundaries, and the key word here is divide because they're moving away from each other. We have convergent boundaries. Our key word here is collide because they're moving towards each other. And finally, we have a transform boundary. Our key word here is slide because they're sliding past each other in opposite directions. These are the three main types of plate motion that we're going to be talking about. When we look at a tectonic plate map, and you've seen this map before in another video, but now when we look at it, we see that this map not only shows the name of each individual plate, and we can see here in brown, this is the North American plate. This says that this is the Pacific plate because this takes up the ocean floor under the Pacific Ocean, African plate, South American plate. But there's some additional information on this map as well. So now when we look at these arrows, we're able to tell which type of plate boundary we have. So if we look at this boundary, this plate boundary between the Eurasian plate and the North American plate, notice how those arrows here are pointing away from each other. Well, they're pointing away from each other. That's a divergent boundary. Okay, so divergent boundaries, remember, divide and the plates move in opposite directions. Let's look down here. Let's look at the South American plate. Notice here at the South American plate, between the South American plate and the Nazca plate and the Antarctic plate, please notice that the arrows are pointing directly at each other. Remember, when we have arrows that are pointing directly at each other, that means collide, and the plates are going to be moving toward each other. And finally, here, if we look at the map, we can see that here on the coast of California, we can see that the North American plate is moving toward the south, east, while the Pacific plate is grinding past it to the northwest. And so we can see that these are sliding past each other. This is a transform boundary. So lots of times when you look at tectonic plate maps, you're going to find that they include information like what type of motion is present at the plate boundary. Guys, before I, because it's been a few days since we talked about this, before I stop for the day, I just want to remind you, why do tectonic plates move? Tectonic plates move because there's heat deep inside of the Earth that is trying to escape. Right? We know that heat always moves. Thermal energy always moves from places where it's cooler to, or places where it's warmer to cooler areas. And so we have these huge convection currents that together form convection sails that drag these plates. As the rock in the asthenosphere moves, it drags these tectonic plates resting on top of it along. And depending on the motion of the convection cells really shows us the type of motion for the plate. And finally, remember, just a few inches in a year. After all, we are talking about this rock in the asthenosphere where we have these convection currents. We're talking about rock that is soft and weak. Remember, we called it semi-solid or semi-liquid. We are still talking about rock though, so this rock is not going to it's not going to be flowing very quickly. So it's going to flow very, very slowly, and that's on the magnitude of just a couple of inches a year. All right, guys, that's gonna do it today for a quick review of tectonic plates and the three types of plate motion. I need you to start working on those words: divergent, convergent, and transform. I hope you get this great day.